Thanks for joining. Today, as we plan, is episode 23, and which is a part 3 of design pattern. Introduction about myself. I'm Jitendra Jha, working in IBM as a senior technical architect. You can follow me on my Twitter. And the agenda for today is pretty small. Actually, we are going to talk about structural pattern, and we are also going to talk the behavioral pattern. So two design patterns we are going to talk. In the last episode, we talked about two design pattern. And on the first episode, we talked about what exactly is the design pattern. So as usual, some house rules. Please mute your mic, keep adding question in Zoom, and I will try to answer all those questions in last 15 minutes. So in the last 3 sessions, as we discussed, gang of 4 patterns consist of 23 patterns. And it has been categorized in 3 groups, which is a creational pattern, structural, and the behavioral pattern. We did saw a creational pattern in the last episode. Today we are going to see one example from the structural pattern and one example from the behavioral pattern. So let's start on code directly. So structural design patterns are the design patterns in this group which focuses on how we can structure various classes. So if we go back on this diagram or this table from 6 to 12, all those patterns are talking about how do you structure your Apex classes or classes in such a way that it is easy to maintain, easy to read. So let's try to understand a problem. So let's say the problem we have is we need to write an Apex class which can take a credit card information, also check if the credit card is valid or not, perform payment operation, and save the subscription ID for the future payment. So like in the payment gateway industry, we really don't save the credit card information directly into the database. So for the security purpose, normally instead of saving credit card, we have a proxy ID. Sometimes that ID is named as a subscription ID. And we can use that subscription ID for all the future in transaction without even saving the credit card. So let's assume that's a subscription ID and how we are gonna do it. So what I will do is I will open my developer org. 1 minute. Okay. And what I will do is let's start with credit card information itself. So I will go ahead and I will create a class named credit card detail. And let's add some methods here. So first of all, what are the attributes of the credit card? So we might need, let's say credit card number, and then we might need a date of expiry of credit card. So I will say expiry date. Then for the credit card, whenever we are doing the credit card transaction, we need a CVV number. So I will say CVV number. And then also, let's say we need to save the proxy credit card ID, or you can say the subscription ID. Okay. So first step we will always do is we will ask for the credit card information. So what I will do is I will create a method saying public return type is void and saying get credit card info, and let's pass some parameter here. So some of the parameter I will say is I will need credit card number. So I will say we will need card number, we will need expiry date, and we also need, let's assume, CVV number. And let's assign these local variables. So any variable like defined at this level is known as the class level variable or instance variable, and this is the local variable only for method. If I use something like this, the meaning of this line is we are referring this variable. If the name is duplicate and you want to refer the variable defined at the class level, you have to use the keyword this. So I am saying whatever the value in the card number, assign that here. Same goes with this dot expiry date. Same with this dot CVV number. Okay, let's try to save. So we have one information. So let's assume that user entered their card number, their expiry date, and the CVV number. We do need to have a method which will be returning a boolean and saying, is this card valid? And here we can have a so let's say sample boolean is valid, and we can do a very basic validation, something like card number dot length. If that's equals to 16, it will return true, otherwise it will return false. And then let's print a debug message saying that is credit card valid, and we have is valid variable already computed, and let's return this one. Same way we can have system.debug here as well, system.debug. So that's just a sample method. Let's assume this is going to do actual work, do the integration, do the web service call out, but just to keep this session simple, I'm going to write some dummy methods here. I will say credit card information received, and let's print credit card. I will say card number here. So now we have two methods. If we go on our requirement, let's see. So it says we need to write an Apex class which will take credit card information, done. Check if it is valid, done. Perform payment transaction. So let's assume that we are going to have a method, say public void pay, and we can have a dummy statement saying system.debug payment success by credit card. So that's if you want, we can print credit card number as well, but that's fine. Now let's see how everything is gonna work. So now we also need to have save a subscription ID. What we can do is we can say public void save subscription ID. Let's say subscription ID is some value we will receive from a web service call, and let's print that. Credit card proxy number or subscription ID which we received, let's assume from the web service call, is this one. Now in the real world, it might be possible that not everything in the same class. At the moment, for the simplicity, I'm writing everything in the same class, but it can span over multiple classes. So let's assume this is the scenario, and now what we have to do is we have to see how things are going to execute. So we need one new class. Let's assume that new class name is something like process payment. And what we can do is we can create a static method here. So let's assume this is the client class. assume client class, lots of code here. And for the payment purpose, we are going to write a method saying public static void initiate payment, let's assume. Now the thing about is, if we go on our requirement, whenever you want to pay, so it says that we have to perform a transaction, payment transaction. Now there has to be a proper sequence we need to follow. So sequence number first is we need to get the credit card information from the user who is on the website or the e-commerce community cloud from Salesforce. I will say, let's say credit card object equals to new credit card. So first we need to do is we have to get the credit card information for the website. So I will say ccc obj dot let's say credit card information, this method, it's a public method. Now this method needs some parameter. So very first parameter is credit card should be 16 digit, right? So this is a credit card number. We have to pass expiry date. So let's say whatever is the today's date, let's hard code it, add let's say 12 months on the today's date, that would be the expiry date. And then let's pass 3-digit CVV number, which is let's say 111. So now we got a credit card information. Before we are doing any payment, we need to make sure if the credit card is valid or not. So we have to say, is card valid? So let's see if that's the method name we have written here. So method name, yes, is card valid. All it is simply checking is it's a 16 digit or not. But it can be a number of ways to payment. Like most of the bank, they validate if the credit card is valid or not by holding $1 payment, those kind of stuff. Now what we will do is let's pay. So we have a method pay. And now let's assume that we got some value subscription ID. So I will say ccd dot. So now in the subscription ID, we have a save subscription ID, but the problem is we also have to get the subscription ID. So I will say create one more method. I will say get subscription ID. And let's return some random value here. Okay. So what we will do is we will call okay. We will call set subscription ID. It needs a string, and let's assume that we are going to get string from here. So I will say cc bj dot this. Seems it's not getting compiled. Okay, return type is actually string. So once we are done, we would be doing this. And let's call this method. So it's very easy. We are going to open anonymous apex, which is control E, and we will say initiate a payment, and let's see how the method and everything is going behind the scene. So if we see first, we are calling get credit card information. Let's assume the user is entering credit card information from website. Then we are checking is credit card valid, and then we are checking let's pay it and then save the subscription. If I go on log, and let's say I only want to see the debug statements. So as you can see that credit card information received is this one, credit card valid, that is true, payment successful by, so this is the sequence basically. And then we are seeing credit card proxy number subscription which is received is some number. So Now, at the moment, it seems pretty easy, but let's assume that they are, and this is again a simple example. Right now, there is only 4 or 5 methods. In the real world scenario, these methods can be so large, interdependent. We cannot call this method before this method. We cannot call pay method before valid method, and we cannot call valid method without we are getting a credit card information. So indirectly, sequence matters. Now there is no guarantee this same sequence is going to be in future. So let's say there is some more change and there is one more layer of math, let's say authentication we need to get. Assume if this method is being called from 20 different places, or this method is replicated in 20 different places, it would be very hard to make a change. It would be a really problematic or knowledge transfer session to any developer that, hey, you have to follow this exactly, this sequence. So we have a huge dependency on constructing this. So in short, the problem with this solution is, if you allow me, what just happened is we created a process payment initial solution. We got all the method. Now all method are dependent on each other. You cannot change the sequence, and you would need to write this n number of line multiple places at multiple time, and which is really a not a good design pattern. So what Gang of Four suggests is, so basically we just talk about the challenge. Sequence must be follow. Every client or every Apex class needs to make sure exact sequence is followed properly. Now the problem is this code is already written. This 4-5 method is already written. If I go back here, we just tested, okay, this method is working fine. This method is working fine. This method is also working fine. If we plan to restructure this code, it would be really a project risk. Every testing has to happen again, and it might be possible that we don't have that much time. So we need to do something here that without even changing this code, all this core code, which is already tested, how can we structure our class in such a way that it would be easy to use and easy to change in the future if needed? And that's what facade pattern talks about. So in English language, normally the facade is simply a face of building. In this design pattern, we encapsulate complex detail and we provide very simple interaction class. And what we do is we try to focus on avoiding change in existing code. So if you ask me that, so this is one client, if you ask me how that can be the facade pattern, it would be very simple. All you have to do is create a new Apex class, say facade, and just make one method saying something like public static void, say pay using credit card, and you can input some values here, maybe credit card information or something. Right now we have hard coded, and all this method would be here. So now if anyone wants to do, and let's make some changes here. So for an example, you can provide the credit card information here, expiry date here. You can make some modification, and every client class. So right now this is a process payment. Let's say there is some another class. What you can do is you can simply call this facade and call this method. That's it. Now client don't need to worry about what is the sequence and everything. Again, we have to provide some parameter. Another place where the facade is very useful is normally in the test classes. So for an example, when you're writing a test class, let's say for opportunity. Now before opportunity, you need to create a lead. You need to convert a lead. That lead becomes account, that lead becomes contact, and then you need to create an opportunity. So if you think there is around 4-5 steps, instead of writing code every time to create an opportunity, what we can do is we can write a centralized facade pattern just for opportunity, and that will generate the test class for that opportunity. So there's so many places we can use facade pattern. The fundamental rule of the facade pattern is Write a simple interface, hiding all the complexity and keeping an encapsulation. Now, like in our very first session of the design pattern, I talked about, right, that whenever we talk about design pattern to someone, right, there is always an argument. However, the fundamental is design pattern never says how do you want to implement it. The same facade pattern can be implemented in n number of ways, but all we have to do is stay to the fundamental, and the fundamental is we have to hide the complexity, and you can do it in n number of ways. The example which I just display is just one of the way. So that's all about facade pattern. I hope you understood this topic, and let's go on the next design pattern. So this is what we did. So initially process payment was here. Actually, my diagram should be changed. It should say process payment 1, process payment 3, process payment 4, and all those clients would be calling to the payment facade. And this is handling all the complexity. What is the sequence and everything. So another question here is, let's talk about the next design pattern. So let's assume that we got a new problem. Now this is some a little bit related to the previous one, but let's assume that right now our program only supports payment using credit card. What do you change and what do you do that in future if they ask, okay, you have to pay using debit card, you have to pay using PayPal? Now the challenge with this requirement is, while writing a program, there is no way you know in advance that what the user is going to choose on the website. Sometimes user can choose debit card, sometimes they can use credit card, PayPal, right? And there is no guarantee. There is only three type of the payment. In the future, there could be n number of ways. Every country have their own way of payment. You can use Venmo. In countries like India, you can use a wallet, those kind of stuff. So the problem, we cannot do hard coding, we cannot do if and else. What can we do that during the runtime or while the program is getting executed, our program should be intelligent enough to decide that how do I need to pay. So for an example, what I'm going to do here is, I will keep this one. So it might be possible that you're already using this concept. I will not tell you what is the name of the design pattern I'm going to do, but you might, this is one of the most common design pattern we always use. And the fundamental of any design pattern is an interface which gives you the runtime polymorphism mechanism. So what I'm going to do is, it doesn't matter it's a credit card, debit card, or PayPal. The important is you always need to pay somehow. So what I will do is I will create an interface. Interface as a best practice should start with I. I will say I payment strategy. And let's assume that it has let's say method boolean pay, very simple method. Now what we will do is any kind of the wrapper class. Okay, what happened? Now what we will say is any wrapper class or any class which have the information about the type of the payments, for example credit card, should implement this. So now this class already have a payment name pay or method name pay. Okay, like public interface. That is right. That's what I'm doing here. And I will go here. Public void. Okay, it's not actually my bad. It's a void, not boolean. Okay. What will happen is, let's try to save. Now what we are going to do is, let's say we want to add a capability of the debit card. Then what I will do is I will create a new class. I will say that class name is debit card. I will copy everything here. And let's see, we need card number, we need expiry date. Now in the debit card, you don't need CVV number, you need PIN number. So I will change that parameter. So CVV number would be replaced by PIN number. Now in the debit card, you really don't get any subscription or anything, but that's fine. I will say debit card information received. Is debit card valid? I will say payment success by debit card. And I will say debit card proxy number is here. So now what just happened is I just added a support for debit. Now, one thing to notice, right? It can be so these kind of the method where it says is card valid, get subscription ID may not be needed. So for an example, if you're using a PayPal is not a card, right? So in case of PayPal, you would be having is account valid, right? PayPal does not need card number or expiry date. It needs a username and a password, or maybe the auth token. We don't know. So basically, we want to keep our metadata information about the source of payment independent of the method pay. Whatever the mechanism, pay method would always be there. So let's see what we can do now to have everything ready. So what I will do is I will create a new class and I will say, let's assume payment processor, or maybe what I say, yeah, payment strategy demo. And what I will do is I will create a method here, public static void initiate payment. And what I will do is, right now I don't know what is the source of payment. It can be credit card, it can be debit card. However, if you see, either it's a credit card or it is a debit card, both implements iPayment strategy. So just make sure that there is iPayment strategy here. So what we will do is we will have iPayment strategy. Let's say this is a payment object we are going to receive, and this payment object is going to call the method pay. Now we know that whatever the means, right, this is always going to have a pay method, because credit card, debit card, both implements payment strategy, and the payment strategy has a pay method. Very simple. Now what we can do is we can go in the facade, right, and let's have public static. In fact, rather than facade, what I will do is I will rather refer my anonymous. So let's assume that I know that during the checkout, user selected the credit card. So I will have something like this: credit card detail equals to new credit. Let me go in facade. I can simply copy this information. Okay. At the moment, I'm not worried about the payment, is card valid or save subscription method. All I'm worried about, let's see if I want to now do the payment. What I will do is I will go in my this class, and all I have to do is I will say initiate a payment, and this CC OBJ is unknown. It can be credit card, it can be debit card. So let's assume that someone selected a credit card. Now this method or this class is independent of what user has selected. It will simply call pay method. It is assuming that whatever is being passed to this method is this interface, and this interface has a pay method. So it is responsibility of a class that, and that is the advantage of the interface. It is a contract. If credit card implements this interface, that means it does has a pay method. So it makes the job a lot easier. If I execute, and now if I go and see the log, it says credit card information received, payment is successful using credit card. Now let's assume that instead of credit card, they want to pay using debit card. Let's say debit card has been selected. Actually, it should be get debit method. And I will have same, let's say get debit method, and I would be executing this. So again, for us, the important point is this class. This class, while we wrote a code, we don't know what can be passed in iPayment strategy. Here it is getting passed credit card. Now I'm calling a debit card. However, I'm not changing my code. My code, whatever I written is as it is. When I'm calling my code, at that time, I'm just passing some parameters. Sometimes I'm passing credit card. Sometimes I'm passing debit card. So let's run this. So now you see debit card received, payment success by debit card. Here in this example, credit card received, payment by credit card. So that's the beauty of the way we have written a code. We are not changing our code, and the key in our code is interface. So whenever you find yourself in a situation where you don't know what user is going to choose, which is unknown, try to use an interface. Try to pass an interface to your method like we did here. We are passing interface. We don't know what this interface can be. But the thing is, the fundamental rule about the interface is a contract. Any class which is using interface must be implementing the method provided by interface. In our case, it is a pay method. So if you think through it, right, what we just did, we have a strategy in a place that what would run during runtime. There is no if or else in our code in our while we wrote this code. It's pretty straightforward. There is no if else anywhere. All you're doing is you're passing algorithm at a runtime. And this design pattern is strategy pattern. And the simplest definition of the strategy pattern is we decide our logic at runtime. And like I said, this is one of the most common. So one of the most common design pattern is singleton, which we normally use in Salesforce to avoid duplicate execution of the trigger and to avoid hitting governor limit. Another most common design pattern is the strategy pattern, where we use an interfaces, we pass an interfaces, and that interface can be anything of our choice as per the demand. So that's as simple as design pattern. Again, like I said, always, you can refer my Apex design pattern book, where I have covered almost all of the gang of 4 pattern. I have a table at the end of each chapter, which summarizes when to use which design pattern, what is the disadvantage, what is the advantage of the design pattern over each other. And that table will help you to avoid any confusion that what to use when. Again, you don't need to learn this code. Like I said, always, you always need to understand the fundamental, and the fundamental of, for an example, strategy is deciding an algorithm at runtime. Now you can do it using interface. If you want, you can do using inheritance, using parent class and the child class, but this is actually the core concept of the design pattern. Again, there are some URL like solid principle. Almost all the design patterns are dependent on the solid principle, which was our design pattern episode 1, episode 21, basically. we also talked about how the trigger factory pattern works in previously. So that's it about today's session. We almost finished like in 40 minutes. So we have a lot of time to do the Q&A. So any question from anyone? Rex, Michael, anything from your side?
Yeah, can you hear me?
Yeah, I can hear you.
Yeah, I got a question about similar thing with different classes and different methods within those classes. I got I've been working on a batchable a batch job, and this batch job this batch job, what it does, it updates a number field based on the value of the formula field, and the catch is it works on opportunities, the opportunity object, and each opportunity needs to go through an approval in order for in order for that field to be editable. Now I've got all the code running in one class, and I feel like I could split up like you've done here into different in different classes and then kind of call them from one class to make them a bit more manageable. What are your thoughts on that? Because I've got them running right now in just one large messy class, and even the test class that I have testing this code is quite messy, and I'd like to clean it up a bit.
Yeah, Rex, very good question. And my suggestion is follow the solid principle. You really don't need to follow any design pattern. In solid principle, S stands for any class should have only single responsibility, and any class should have only single reason to change. So in your batch apex, right, normally you should not write your logic in execute method. You should take a helper method, or maybe you can follow the enterprise pattern. Now advantage of that approach is same helper class can be called from maybe trigger or maybe queuable kind of stuff, right? So in your class, let's say you have opportunity and you're populating field, right? And then there is an approval, right? In my opinion, upfront, I see two classes in front of me. One class which handles the approval part, and the only reason that class will change if there is a change in the requirement of approval. Okay. Another class, I think, is the field population, cloning the formula field to the actual field. That is another class I'm expecting, and the only reason that class will change if number of fields will change, or the requirement about populating those fields would be changed. Okay. I will go one more level beyond, not really related to the design pattern. What I will do is I will create a custom metadata about field mapping. So from which field to which field you are copying, right? You really don't need to hard code. Today requirement is you need to copy 4 fields. Tomorrow the requirement is you need to copy 10 fields. Your code should be written in such a way that you only update the custom metadata. Today you have entry for 4 field. So for an example, field A should be copied to field B. Field C should be copied to field D. Add those values in the custom metadata. In your Apex class, use a dynamic Apex. There is a concept. So using dynamics Apex, you really don't need to say opportunity dot name field, opportunity dot stage field, opportunity dot probability field. You don't need dot. You can say s object dot get field, in the bracket you provide the field name as a string, it will give you the value. That's a dynamic Apex basically. So in my opinion, you combine these 3, you would be the good spot.
Yeah.
Go
ahead.
Yeah, and for the test class, right? Like I said, any test class which need data preparation, we have a setup method in Salesforce. However, instead of writing everything in a setup method, create another method, just like a facade pattern, saying that create initial opportunity data. Now, you can create in multiple way. Either you can create a lead, convert it to account or contact, or you create account or contact, then create quote, order, opportunity, whatever the sequence, right? But do not create test data multiple time in the multiple objects and then call that. Maybe you can name a class saying test setup factory, test setup data or something, and call that class in your test class. So at least test class will have your two classes.
Okay. One issue that I was running into was, so I wanted to have in my test class, I wanted to have one method to create the test data, and then the other method to practice. Oh yeah, I forgot to mention this batch job. I used the schedulable a schedulable class to do it every day. So because it's a daily batch update.
Right.
So in the test class, the issue I was running into is because I had the method create 10 records, and then another method to schedule the batch. Now the issue I was running into is the schedule method always ran before the test data was completed. So the schedulable method always failed because the batch data had not been created yet. Is there a way to have one method wait for the other method to complete?
Yeah. Have you used the test.start test and test.stop test method?
Yeah, I used it in the batch.
Yeah, so basically what you should do is create in your test class, create a data first. Okay. And then use a test.start test and you call your scheduler. Okay. Do not call batch, call your scheduler and then say test.stop test. You don't really need to call batch explicitly because scheduler is already calling it.
Right. Yeah, correct.
So, yeah. So and any assertion which you're trying to do your assertion after test.stop method. So what test.stop makes sure is, or any your asynchronous job gets executed before you do your assertions. That should solve the problem.
How do I have it wait for?
So
how do I have the schedulable the method that does the schedulable class that calls the schedulable class? How do I have it wait for the test data to finish
yeah, so
being created?
so let's example. I'm just writing a pseudo code. Okay. So let's say public static void test method one. Just an example. Okay. What you will do is call class dot test data. Let's assume that this method or this class, maybe some class test data creation. Let's assume that it is going to create your data, whatever is needed for your scheduler. Okay. Now you will do something like this: start test. Okay, and then you can call scheduler class from here, and let's assume you have done that. Two ways to do it: either you call system.schedulable, or you call execute method directly by passing the null value. Then you say test.stop test. Now this line will cause that all async job finishes now. Now you can do all your assertions here. So this is the sequence you should follow.
Right. Okay. That's the mistake. Because I think the mistake I had was so instead of having a separate class for the test data creation, I had the data, the code actually running inside of the same method.
So one thing about, right, again, I learned it very hard way. Follow some of the, so first of all, right, follow kind of 20-20 rule. 20-20 rule means no method should be greater than 20 number of lines. Okay. So basic, what will it will help you is, right, it will help you to cover the code coverage. So for an example, right, there is two way to cover this test class as 100%. Way one is I do the functional testing, and functional testing means, okay, I will call everything in the sequence that, okay, get credit card information, right, and is credit card valid, pay. So in this example, right, if I give the wrong information, it would never go in the pay method, it would never go in the save subscription method, right, because credit card is not valid. So this is a functional testing, unit testing. Either I can do this way, or I should go functional testing, see how much test coverage is there, and any class which is missing, I can directly call that class. So if my class is small, so for example, if I need to test cover this method, I really don't need to go this whole step. I can directly, even if it is a private, test class can access the private methods. I can simply call this method and I can assert on those value. So small method is equals to best possibility of the test coverage.
Okay.
Yeah.
And one more question about code coverage. In one of my same scenario here, the batch job, I have a what's the method? It's I believe system.update method, and if it's success, do this. If it's error, do this. The issue I'm running into, I'm getting like 92% code coverage because in my data there's literally no way of me creating an error to test it, because if the criteria wasn't met on that record, it would never even get to that point. So how do I get full coverage for something like that?
Perfect. So let's say you having something like this, database dot update, right? Just an example. Let's say list of record, all or none is, let's say, false. Now you are getting kind of save result array.
Yeah,
it's a
correct.
It's a pseudocode. Okay, lst result. Okay, something like this. And then you have some kind of the for loop saying that for example, save result sr equals to lst, let's assume result, and we have something like this, sr dot is success, and then we have else part. Right now your problem is you are not able to cover this part, right?
Yeah, correct.
Perfect. So like I said, this is the before code. If I were you, what I will do is in after code, I will create a method, maybe private method. I will say private void parse result. Okay. And then what I will do is I will pass save result ID here. Okay. I will have this part here. Okay. Now what will happen is in your case, right, there is no way to generate an error, correct?
Yeah.
Perfect.
Yeah,
what I will
based on the system configurations today.
Exactly. So what I will do is I will try to update contact by making email field invalid. Okay. I will get an error. I will pass that save result to this method. Now the advantage of this private method is it is not necessary that it needs the save result of opportunity. It can have a save result of any object, right? So now you're passing contact, and in contact it would be always false because you cannot have an invalid email address in the contact, correct?
Yeah.
So This is exactly what I was talking about, 2020 rule. You have a small method chunks. It is very easy to cover the test classes. Okay.
Yes, even if, so pass it something like a contact that's not related to the S object that I'm actually working with.
Yeah, because you just need a code coverage, right? Today you don't. So first of all, right, today you're not expecting there is any error, but there is no guarantee if tomorrow what kind of the validation rule your project can introduce, right?
Correct.
What kind of unique index? There is n number of way things can fail, right? I mean, someone might give you a suggestion that, okay, why do you even need to care about the save result? Remove that piece of functionality directly, right? That is one kind of suggestion you can get, okay? But I would say it's always safe. It is always good to write a safe code. Something is not failing today doesn't mean it is not going to fail tomorrow, right?
Right. Thanks, I'll give that a shot.
Yep. Okay, so thank you so much everybody for joining. I would be posting this episode on our YouTube channel. Next week would be the last week of our Path to Code episode, and there is no agenda for next week. Next week is completely Q&A. Come with any question, we will chat, and we will try to do the brainstorming. If I can answer, I would try my best. Otherwise, I will come back or on blog, on any other social channel. Okay. Thanks, everyone. Have a nice day. Yeah, I will upload all the previous video soon. Thank you.
Thanks.
Yeah.
Take care.